So we were in that one, which is the Earth magnetic field. The Earth magnetic field. The Earth magnetic field. Okay, so before we explain about the Earth magnetic field, I have one question here. Let's say we have the magnetic field like this. This one is the magnetic field. And we have the different magnetic field. We have this magnetic field. We have this magnetic field. We have this magnetic field. So when you see this one, this A and B, they are different magnetic fields. In the first one, these magnetic fields are parallel. So which means they are uniform. So this one we say uniform magnetic field. So this one is uniform magnetic field. Uniform magnetic field. What of the one for B? This one is a pairing magnetic field. They are pairing. This one is a pairing magnetic field. They are pairing. And you see that in the first one here, this way here, and the other one, you will find this one is strong, this one is weak. Why? Because we say they are closer together where the field is strong. So this one is strong magnetic field, and this one is weak magnetic field. Why? Because this one is spaced, and this one is closer together. So that now is what we have. So the Earth magnetic field now. What is the Earth magnetic field? In the Earth magnetic field, initially, when we were given the properties of a magnet, the second property was a directional property, and we were saying that if we take a bar magnet, then we suspend it freely. If we take a bar magnet and we suspend it freely, and we make it swing, you will find that it will swing, but finally will rest facing north direction of the Earth and south direction of the Earth. What is that one tells you? That means the Earth itself is a magnet. The Earth itself is a magnet. That's why now this one we say the Earth's magnetic field. And the Earth magnetic field is having the magnetic field like this. This magnetic field is called the Earth magnetic field. So this one is the Earth magnetic field. It is running in that direction. And then this one is an example of a uniform magnetic field. Because when you check this one, they are uniform and they are parallel to each other. So this one is a uniform magnetic field. Uniform magnetic field. Uniform magnetic field. And this one now is what we call the Earth magnetic field. So then we have said that the Earth is a magnet. It is having a special magnet also. What will happen now if we take a bar magnet and then we place it on the surface of the Earth? What will happen if we take a bar magnet and then we place it on the surface of the Earth? For example, let's say we take a bar magnet like this in north and in south. What will happen? This means here we have the interaction of two fields. The first field is the Earth magnetic field, and the second field is the bar magnet field. Bar magnetic field. The magnetic field to the magnet, and the magnetic field to the Earth. What will happen now? And then initially, when we were giving the characteristics of the magnetic field line, we say that they will not cross each other, or they will not intersect each other. So what will happen in this one here? So we will take an example here. For example, let's say we have a bar magnet. This is a bar magnet, and in that bar magnet, this one to be south pole and this one to be north pole. And remember, we place this one. Let's say, for example, we place it on the surface of the Earth. What will happen between the two fields? So this one now is what we have. First of all, we have the magnetic field pattern around this bar magnet. We should be having the magnetic field pattern around this bar magnet. This one is the magnetic field pattern around this bar magnet, and then we show it using an arrow which is always running from north to south. So then, if we have now the earth magnetic field, this one is the earth magnetic field, which we say it is an example of a uniform field, and it is running also upward, like this one here. Okay, because this one is the earth magnetic field, then it means we shall be still having the magnetic field running like this. Ikifika hapa, it will be forced to enter into the south pole here. So this one now will be forced to move like this. So this one also will be forced to move inside. This one the same inside. This one also the same inside. So this one now is what is happening now here. Why? Because we say they will not intersect each other. We will not find this one intersecting with this. That's why now we have this space. Even upward here, we still have some which is forced to move upward, and then we have this forced to move upward, like this. So this one is what we have now. That one is what we have now. Okay, then at this point, this one is moving upward, and this one is moving downward. So which means they will be cancelling each other now. This point we shall have x, and this one also we shall have x. What was the meaning of x? That one is a neutral point. So then we have this one to be a neutral point. This one is a neutral point. Okay, this one now is when we make place the bar magnet at the surface, and we make this one north pole and south pole. What if when we interchange the poles of that bar magnet? Let's say we interchange the poles of that bar magnet. We have the bar magnet, this one is the bar magnet, and then we also place it on the surface of the earth, this one to be south and this one to be north. We interchange the polarities. Okay, we will have two fields also. We have the field to the bar magnet, this one here, which is also running from north to south, and we must show the direction. That means it is running from north to south. What will happen now? Because we have also the Earth's magnetic field, which is running upward. This Earth magnetic field, you will find the Earth's magnetic field moving. When reach this point, it will be forced to move like the one for the bar magnet. So this one now will be forced to move upwards like this, and then that one is the pattern which is formed by that Earth magnetic field. So this one now is what we have. This one is what we have when we interchange the polarities of the bar magnet. So this one now it is also moving upwards like this. And then this one is moving upward because we must show the what? We must show the directions of that magnetic field. Okay, this point also here, it is like this one here. Why? Because this one is moving downward, this one is upward. So then at this point it will be crossing each other. And then when crossing each other, it will cancel each other. So that means at this point there is no field. This one now we will also have a neutral point. We have a neutral point there. And even this point here we have a neutral point. So that one now is what we have about